Good day, viewers. You are welcome. How to solve these exponential equations where we have x dot 5 to the power x equals 50. So to solve this problem, we are going to apply the principle of Lambert omega functions, which states that if we have omega of a exponential of a, this equals a. That is, this a is constant, and we must make sure that what we have here is the same thing as what we have at the power of exponent. That is, the power of exponent must be the same thing as the coefficient we have here. And how we're going to make this thing realistic, and how we're going to make this thing looks exactly like this. Let's get into it. So here we start with this 5 to the power of x. We're going to introduce exponential and ln to this. So here remains x multiplied by, here we have exponential of ln 5 to the power x equals 50. So this and this they still cancel each other, and we have 5 to the power of x. So by rule of exponent, so x comes down here, and here we have x dot exponential of x ln 5 equals 50. So this is not really looks like what we have above, because here is x ln 5 and here is x. So what is missing here is ln 5. That is, we are going to multiply these two sides by ln 5. So doing so, we have this as x ln 5 multiplied by exponential of x ln 5 equals, so we have this as 50 ln 5. So we have gotten what we want, which is x ln 5. The coefficient is the same thing as what we have here. Therefore, we introduce the function, which is omega. So by introducing omega to both sides, so here we have omega of x ln 5 exponential of x ln 5 equals omega of 50 ln 5. And therefore, we are going to choose ln of x ln 5 as the formula implies. X ln 5 equals omega of 50 ln 5. So by dividing both sides by ln 5, here is x equals omega of 50 ln 5 divided by ln 5. So this gives the answer, but wait. So we have not gotten the numerical value for this, because so by plugging this in the Wolfram alpha, we are going to get the value of x, which equals 2. But how can we do it by ourselves? So if you consider from this numerator, which is omega of 50 ln 5, so we are going to work more on this, and this is how it works. So suppose I take out omega of 50 ln 5. So what I will do here is, if I write this 50 as 2 multiplied by 25, then here is ln 5. So from the properties of logarithm, let's say we have ln of x to the power of y. We have this as y ln x. So which means that the 2 we have here, we can take it to the power of this, and we have, so we are going to have this as 25 ln 5 to the power of 2. So we have this as 25 ln 25, which the whole of this is still in this function, which is omega. It implies that we have omega of 25 ln 25. But this 25 ln 25, I want to do something here. This 25, if I introduce exponential and ln to this, what we will have is omega of, so ln 25 will come here, then we have exponential of ln 25, and which is amazing. So we have ln 25 here, and we still have ln 25, which is another constant of ln 25. So therefore, we will now come back to this value of x, which means the whole of w of 50 ln 5 is the same thing as ln 25. So we have x equals ln 25 divided by ln 5. And the ln of 25, so we have it as ln 5 to the power 2 divided by ln 5. So when 2 comes here, we have ln 5 cancelled, and therefore x equals 2. Wow. So which means, so there are some number here. When we plug it here, we can still manipulate it to get the real value without applying the tools. I mean the Wolfram alpha tools. So we apply it here and we got the value of x, which equals 2. So we can just try to verify it if it satisfies the exponential equation we are given. So we have x dot 5 to the power x equals 50, and when x equals 2, we have 2 dot 5 to the power of 2, so which this gives 2 dot 25, and 2 dot 25, which is 2 multiplied by 25, equals 50. So therefore x equals 2 satisfy this equation. So thanks for watching, and thanks for taking your time to this stage. So please don't forget to subscribe to this channel for more exciting math content like this. I will see you in the next video. Any comments in the comment box, so it's allowed. So try to engage in our video, and I will see you in the next class. Never stop learning. Bye bye.